Let us start the lecture number 10 of this module, that is module number 2, and today I will discuss about the few numerical problems, and also we draw some wave shape for given inverter operation, and then I will introduce about the converter charts. First problem, if you will let us see some numerical problem number 1. In this it is said that the monopolar HVDC link which is energized with the 3-phase 50 hertz 400 kilovolt source, this is AC source because frequency is given. The DC current is 1 kiloampere and the rectifier which is 6 pulse bridge converter is used and the DC voltage is 500 kilovolt, and for the delay angle of 15 degree you should find the 3 parts, that is find the commutation resistance, find the commutation angle U, and if the voltage, this AC voltage is reduced to 200 kilovolt, what will be the commutation angle U, assuming the current is same because the current can be maintained by the another end of inverter. This was the so simple problem, and if you will see here, simply just you use a relation we derived for first we have to see what is this here U. U is not given to you, but you can use with the starting U is less than 30 and you can satisfy the equations, then it is okay, otherwise you can go for this more than 60 degree. But here you will find here while calculating U is less than 60, and then the relation this V output here is your VDU cos alpha minus your RC ID. This relation we derived, and you see here it is asked that what is a commutation resistance, not reactance here, resistance is asked. So, your VD is given to you, it is monopolar, means it is only one bridge is there, the snow bridge is mentioned, means it is only one bridge, and this voltage is given to you, this is your nothing but your 500 kilovolt. Now, this VDO is nothing but your VDO is defined as EM over pi. This we have already derived very well, this expression. And now this question only, what is the EM in this case? It is given to you, it is 400 kilovolt AC 50 hertz, means this voltage is your line to line voltage and this voltage is your RMS voltage. Nothing said means it is valid. So, this voltage is your V line to line voltage. Now, here this EM is the phase voltage magnitude. So, here it is your EM, I can write EM, it is nothing but under root 2 V phase voltage. So, we can write here what will be the phase voltage here under root 2, here it is your 400 over under root 3, and now this will be your kilovolt. So, this was expected that you should write EM here in this expression, and then you can write now what we are going to have here. You can put this value here, this under root 3 will be cancelled, and we are going to have 3 under root 2 into 400 divided by your pi, cos it is given your 15 degree minus RC. Now, this is ID is 1, remember it, all the units should be in kilo because this is in kilo, this is in kilo. So, 1 is also in kilo, so it is cancelled. So, this is I am using 1, it is not that you are using here 1000, and once you are going to solve this, you are going to get your RC value, and it was so simple, and your RC value as per our calculation it is coming 21.78. So, it is 21.78 ohm. So, this value is now commutation resistance is asked. Sometimes it is asked what is the commutation reactance, then you can simply here this RC value, you know this is RC is nothing but your 3 by pi XC. So, if sometimes here the reactance is asked, so then you can just we will see in the next problem. Now, to find the commutation angle 2, we have another relation, and that relation shows that your VD is your VDO by 2 here cos alpha plus your cos alpha plus U. We know this expression. Here also this VD is given to you, this value is here, it is known to you, cos alpha, alpha is given to you, here alpha is also given. Just put the value. Only you should be here causes are careful, that is to calculate this. And then here it is, this value is normally known as delta, and the delta is coming to be, as per my calculation, it is coming out to be 27.714. This is angle, then you can calculate what will be u, just subtract 15, you are going to have 12.714. And you can say this is valid because u is less than 60 degree, that is 2-3 valve conduction. Now, third problem, again it is based on the same which we are going to use. It is said that your this voltage is reduced to 200 kilovolt, find the commutation angle. Here also the delay angle is not going to change, it is said for this delay angle you have to calculate this. So, here we are going to use only now from this expression, it is going to be 500 volt, it is not saying, we have to calculate this voltage now, because once your AC voltage is going to dip, this voltage will be changed. So, this voltage is not known to you, because this was the valid when we are having the 400 kilovolt. So, once there is AC dip, this because the firing angle is same, automatically DC output voltage will be changed. So, we have to calculate this, what will be your VD now with this value, means here it is going to change, that I can say prime, and this prime corresponds to your, it is your 3 under root 3 EM by pi, and this EM we used here, that we are going to use here, this will be under root 2 into 200 kilovolt. Just previous here we use here 400, now it is 200, and again your cos alpha, that is 15 degree, your RC we calculated, it is not going to change, here it is your ID is also same. So, if you are going to calculate here, you are going to get some the DC voltage. Once you are getting the DC voltage, then here you are going to again just replace here in this expression, and then you can get again the delta from here, because this VD is now calculated from here. Another way, just you can use the ID, the expression for ID you can again get it. If you remember, we derived this ID expression here, it is your IS3 cos alpha minus cos delta. This ID is same, here this value is changed because the EM is going to change, alpha is known, delta you can, because from these two equation itself we derived this. So, that will be the same. And finally, what we get as per my calculation, here the value is coming out to be here 239, this value is coming 239.11 kilovolt, this is the DC value, and your U here, if you are going to put here, your U is coming 21.425 degree, and you can say now U is changed due to the AC dip voltage. So, this problem was simple, only just you have to see where to apply and what are the things are given, and especially even though earlier also I mentioned here about the taking this EM which is here, which is given here the RMS voltage and line to line. And also we will see in the problem number third that sometimes it is not a monopolar, maybe bipolar, and so many bridges are in series or maybe in parallel, then you have to consider those parallel and the series combination. Now, let us see the second problem. Second problem is similar to the first problem, only difference here the commutation reactance is given to you and you have to calculate the current, remaining things are same. Because it was asked in the previous problem also U, it was voltage reduced to 2, and then here instead of this the commutation, only sometimes what is here people normally skip, it is given the reactance, it is not given resistance, means this value XC is given to you, not RC. So, here this is given to you your 10, now we are putting here 3 by pi multiplied by 10, it is coming out 9.55 most probably. So, it is slightly different. Now, if you are going to put this value here in this expression, we can see here it is again your voltage is 400 volt kV, this is the same expression. Here now this is RC, we are going to get this. Now ID we have to determine, and this voltage is given to you, it is your 500 kV. So in this case your RC is known, now ID is to be determined. And just put the value, alpha is again given here, alpha is 20° delay in this case. Put this value, RC here 9.55, ID, all the things are known to you, and then you can get. And the ID, as per my calculation, it is coming out to be 7 point. It is coming out to be ID. It is 0.797 kilo ampere. Once you are done with this, then you can come back here and then you can calculate here this value delta, because now this VD is known, this is given to you, this is given to you, this is you can calculate. Here you will find, even though without calculating the first part, you can calculate the second part, because already here there is no RC. So just this is given to you 500, this value is this value here, by 2 here you have to just put, and then cos alpha is 20 here, cos 20, and then delta you can calculate, and this value in this case it is coming out, my calculation, it is coming your delta U is coming 4.285, means this value is coming to your 24.285 degree. So this was your second part. Now in third part, again the similar, you have to calculate the DC output voltage for this 20° here, again this is same. RC is now known to you. Now you have to, if this voltage is reduced to this 200, means for the same current now, now current is known, this value is going to be changed to 200 volt, then you have to calculate what will be this VD. In this case ID is now known, and this value again as per my calculation, it is coming out your 246.2 kilovolt, 246.2 kilovolt. And once this is known, now again you have to come back here for this voltage, and here now you have to calculate what will be. In this case it is going to be changed with the new voltage, that is 200 volt, and here it is your value is coming, U is coming to be your 7.94 degree. As per my calculation, you can check it. So this is the very simple, only just you have to see how to apply, just you have to read the problem carefully, and whatever parts or questions are asked, you can just respond accordingly. Now problem number 3. This slightly tricky problem, but once again if you will understand what is the meaning of this. Here it is very clearly said. Let us remove this and then we can go for this problem. It is said it is bipolar link, means we are having here the two links, one is your positive, one is your negative, that is why we are saying plus minus 500 kV, means here there is some here converters, one is a grounded here and there are, it is the two converters, it is said, means a bipolar link 6 pulse operation having the 2 bridges per pole, means here the one pole, this is a bipolar, is a 2 pole, means one pole we are having 2 bridges and that is a 6 pulse. So here we are having one bridge and here we are having another bridge. Mind it, here these bridges, it is not said whether they are connected this side is star delta or something, there is phase shift, then it will be not 6 pulse, it will be 12 pulse then, but it is 6 pulse operation, means both are in the same configuration, whether they are here connected in the like here star star. So this will be also connected in the star star, then both will giving the combined effect of your voltage which is coming here 500, that is directly added, and the pulse is again 6. If here is a change, even though this is delta, if secondary, this will be also in delta. because there is no phase shift here, because both are in the same phase. Here there is shift, but here is same. So, that is why it is written 6 pulse operation. It is inherently it is said that here these are in the same phase here, and that is directly added. So, these two are giving you 6 pulse operation. Now, this voltage is now given to you 500 kilovolt. So, the bridges here is called the per bridge per pole. Here the voltage this means the voltage this and this both are sharing the same voltage. So, the voltage across one here it is your 250 kilovolt, because it is going to be added. So, average both are same, it is assumed that both are same, although it is not written, but if the two bridges are there normally of having the same voltages. But here the current which is flowing, it is ID, it will be the same throughout the bridge. So, it is your 2 kilo ampere which is flowing in the DC link, and it is the resistance of the line. It is saying now this is having some DC resistance, and now we are having the inverter this side, means again it is inverter of this same similar fashion. This is the grounded, and we are having another pole here. This is another pole, bridge of that pole, and here it is your, this is, you can say now we can just, here the current is coming here. This is your inverter side. So, this is the diagram which was asked. This resistance is given to you, it is said is the 15 ohm per pole, means this is the resistance of this, because the total resistance in the circuit will be this plus this for the line, and this will be the commutating resistance extra. Now, the sending end voltage of the link is kept at the rated voltage, mind it, and each bridge is connected with the 3 phase 220 kilovolt AC supply system. Means this each bridge is not each pole, it is each bridge. Here we are having the 3 phase, that is 220 kilovolt AC system, and it is 3 phase. So, this value is again it is your VLL, this is given to you. So, now this is given to you. Now, come here, if the rectifier controller is operating at the delay angle of 15 degree, and the inverter is the extension angle of gamma here is a 15 degree, find this. First it is asking the commutation resistance per bridge RC and the overlap angle of the rectifier end. Now, it is asked for this angle first, this side. Now, this voltage is given to you, because it is said it is operating, rectifier end is operating at the rated voltage, means rated voltage is this one. So, this is operating at the rated basically voltage. This voltage may not be that voltage, it may be again, because this is normally controlling your current. So, from this whole configuration we have to go for a single here, and then we can define it. Now, first take this one single bridge. Here it is your, and this voltage is here, it is given to you, means now I can go for, this is your variable voltage, this is your RC of the rectifier, and this voltage is nothing but we are talking here VDO cos alpha, this is a variable, and this voltage is your 250 volt kilovolt. Okay. Now, we have to put this value, as we know this is expression, this VD is your VDO cos alpha minus RC ID, this is given to you, because you know this RC we want to calculate here, rectifier end, this voltage is given to you, that is 250, we are again writing in the kilovolt. So, everything will be in the kilo. So, here it is now your 3 under 2 into 220 divided by pi cos, this is a 15 degree, minus RC into 2, because the 2 kilo ampere kilo here. This K here basically it is KV, here your KA. So, this K is cancelled. and then from here you can calculate this RC value. RC basically it is of your rectifier, and this value as per my calculation it is coming out to be is 18.49 ohm. Now, this is now with this it is asked that what will be the overlap angle. Again it is similar to the your example number problem number 1 and 2. You have to put this value again here, you know this VD, that is a VDO by 2 cos alpha plus cos delta here, and then you can calculate your U. Now, again you can see here in this calculation you do not require even the current, but you require this value, and this should be clearly known. And from this calculation, if you are putting this value here 15 degree, here delta you want to calculate, this value will be the VDO you can put from here, and the VD is 250 kilovolt, and you will find the delta as per again my calculation here 29.2 means basically U I am calculating, U is 29.2 angle, or you can say delta will be nothing but at 15 degree here. So, this was your the part A of this problem. Now, this B part we have to be careful, because in the B part it is said that now we are coming to inverter side, and the inverter side now you are just see what will be the voltage across here. This voltage which is going here, that is going to be dropped. So, this voltage which is going to appear here, basically this voltage total here we are knowing the 500. So, normally the 500 minus, if you are going to calculate this, you are just drop and then divide by the two bridges. Mind it, here slight mistake you can do, you can see this voltage you can take, and we are taking this drop and then we are putting this value, that is not valid, because the drop here is shared by here as well as here, is not only one bridge. You can just check it here. Let us suppose you are taking this as a bridge of this drop, the ID is given, the resistance 30 volt is drop. So, now the question you can say here it will be 220 kV. You can say this is a 250, 2 ampere is flowing here and then drop and here 220. It is not so, because just think about here, this voltage is 500 minus here 30, that voltage will appearing here, because this is 0 potential. So, this value here the total is going to be 500 minus 30. So, it is 470 volt, and this will be shared equally by these bridges, and this will be your how much 235 kilovolt by this bridge. Now, we in the inverter operation for the single bridge it is now it is 235 kilovolt, and now then you can calculate what is sorry. Now, you can calculate what will be your again with the help of we want to calculate here, we want to calculate this receiving end line voltage. Receiving end line voltage here it is asked the receiving end here we want to know. Mind it, here you can see the receiving end line voltage, we are going for the AC voltage, because this is the receiving end line voltage. You can say this is the DC line voltage, you can say this one also, it is okay if you are understanding this, but it was asked what will be here this voltage. This expression here we know this is in terms of this, we again can write this VD here, it is your cos gamma minus RC ID. Yeah, sorry, here video. You remember here it is a minus when the gamma, if the beta you are using it is a positive. Already we defined all these equations. So, now it is for this case we are having this is your 235 kilovolt again, and here your 3 root 2 we are going to have the VLL of this side and divided by your pi cos gamma is given 15 degree minus RC into ID. ID is given 2 kilo ampere, RC is given because same as it is said already we calculated this value and put it here, you will get the VLL here for this side. And this value is going to be is 208.5 kilovolt AC side. So, it was asked the receiving end line voltage. Basically, it is intention was to ask for the AC line voltage, although you can say the DC line will be of course 235 volt. Now, then it was asked what is the overlap angle. So, again we can use the expression for the overlap angle in terms of ID, and we can use this equation that is your no it was asked the overlap angle. Yeah, we can remove this. This was for your rectifier operation. This expression we can write this VD is your VDO cos beta. If you can calculate the beta, we can calculate the U, because you remember here the gamma is given to you. This is your sinusoidal voltage. Here this is your beta, this is your gamma, this is your beta from here. So, U is a beta minus gamma. So, you can just simply calculate beta, you can get U. So, here this was your RC ID, and if you put this value here, everything is known. Now, the beta you can calculate, it is coming to be your 45 point, as per my calculation it is 45.31 degree. Just put the value, because here it is given to you, this is known, this is known, this is to be calculated, this is known, and this is also known. And once beta is known, then your U will be nothing but your beta minus gamma, and just 15 you can subtract, it is your 30.31 degree, that is your U. So, only just you have to read the problem carefully and just draw the diagram, and then you can know what is asked, and based on that you can solve the problem. Now, the next problem, it was sometimes asked, let us say it is asked to you that you have to write the various values related to this, fill in the blanks or choose the value what is given in our inverted brackets here, and it was very simple I think, and I did not check, but most probably you might have done. For example, the first part if you will see here, this is a commutation voltage of valve 5 and valve 6 are asked. So, from here again I can say what is the, here is the valve 5, and the commutation voltage means what was the voltage before it is going to be fired, means once 5 is coming means it was 3 and 4 were conducting. So, once 3 and 4 were conducting, now for this side here and the 3 here, it is your EB, and here it is your C is always appearing. So, this it will be your ECB will be there. So, this will be your, it is correct, yeah, it will be ECB will be the commutation voltage of valve 5. Then it was asked for 6. 6 means your 5 and 4 and 5 are conducting. So, this is conducting here means it is your EA this side, and always B here means this will be your EA minus EB, that is EAB. So, it was asked that is your answer here. It is your E CB and E your AB. So, it is the commutation voltage of the valve. You can similarly calculate whenever it is asked for the different valves. Now, second was asked that if the delay angle is 110 degree, means your alpha is given here, this alpha, the overlap angle u is given to you, that is a 25 degree, the extension margin angle. Now, you can see here u is less than 25 degree, and your beta, if you will see the beta, if you are going to see how much beta you are getting here, 70 degree, it is a greater than 60 degree. So, here it will be nothing but, and also you see the u is less than 60 degree. So, in this case your extension margin angle will be nothing but your 60 minus u, and it will be your 35 degree, because it was very simply it was given your 60 minus u, from here only itself you can just calculate it. Now, second was asked that whether voltage or current is maintained constant in HVDC link. I repeated several times, HVDC link is operating on the constant current mode and voltage is varied to change the power in the link. So, it was the simple, it was this was the current is maintained, and it was asked to you. Now, second, the presence of source inductance increases or decreases the average DC output voltage. It will decrease. It will be decreasing, because if L will increase, if you will see what happens, just you see the U will increase, it is just current another relation. So, here it will decrease your this, and here this is valid. Now, it was asked the polarities or polarity of homopolar operation of HVDC link is RR, because why it is sometimes people confuse about, if I will say it is R always, so they will certainly understand. So, to confuse about this homopolar and the bipolar monopolar, here it was R and the polarities are written. Basically, in homopolar there are the two polarities. So, it will be always polarities of homopolar operation of HVDC link R, it is both are negative. So, it was asked to write. So, here polarity is negative and both will be negative, both poles will be negative. It was asked to write both negative, you can write. Now, during the inverter operation, valve voltage is positive and negative for the maximum period of the time. During the inverter operation, valve voltage we will going to see in the next problem, it is most of the time it is a positive, very few time it is negative. So, it was, this is wrong and this is your correct. Now, another is called write the sequence of valve voltage conduction duration and with the duration for angle 45 and u is 75. Now, here u is more than 60, means we are going to have 3 valve and the 4 valve conduction operation, where sometimes it is 4 valves, sometimes 3 valves. So, now how many times, like 4 valves, it will be your u minus 60. So, 4 valves will be conducting for 15 degree and your 3 valves will be conducting for the remaining 45 degree. And now, you can write the sequence, you know the 561, then 5612, then 612 and so on so forth, you have to write the sequence, because the duration once you have written means it is clear. When 4 valves are conducting, it will be 15 degree, when 3 are conducting, then it will be 45 degree. Now, the delay angle alpha in 3-4 valve conduction mode cannot be greater or less than 30 degree. It cannot be less than 30 degree. I just explained reason, because the voltage across the outgoing valve will be only it will be positive after 30 degree delay, and then it is will be cannot be less than 30 degree. So, sometimes this very short questions based on your fundamentals of this course of even basically all these are related with the mostly the converter and some link operation. Now, let us see another problem, which is I explained many times for all the operations, whether it is a rectifier operation, whether it is an inverter operation, in both 2-3 valve conduction modes and 3-4 valve conduction modes. No doubt the valve voltage as well as the output voltage for 3-4 conduction, 3 or 4 valve conduction mode is very simple, but it is slightly tricky once you are going for the inverter operation, and which was asked here. You can see in this one it is given the advance angle, it is not delay angle. So, what people slightly I think people do here, simply looking this angle 30 degree, they say it is alpha degree, and then they derive the rectifier operation, which is totally wrong. It is advance angle means that the beta is given to you, and the beta means now alpha is 150 degree, means you are in the inverter operation. So, in this problem it is said draw the DC output voltage waveform on the given sheet, means it is to make a uniform by choosing the appropriate scale of an inverter 3-phase 6 pulse bridge converters operation at the advance angle of 30 degree, that is the beta here 30 degree, and overlap angle is 15. So, we are sure that U is less than 60, we are in the 2 or 3 valve conduction mode. Also draw the voltage across the valve 4 for the complete cycle with the conduction sequence, it was asked. So, to draw this as sheet is given to you, and if it is not given to you, then you have to just draw the various line to line voltage or phase to phase voltage. So, you can draw. It was possible to draw here the phase voltage or line to line voltage. Here upper limb and lower limb you can draw separately, then the difference of this will be your reflected here. So, it was given to you, and based on that it was asked that you should draw this valve voltage. Only here we just said, I just wrote that this voltage was given to you and it was EBC, it was fixed to you. So, let us draw this DC output voltage for this case, where you are given this your beta is 30 degree and your U is 15 degree, means you are given alpha is equal to 150 degree, means beta is your 30, means it is this, and U is given your 15 degree, means you are having 2-3 inverter operation. Just you see the angle and you will draw, you will find it is a inverter operation. So, this is for it is given to you on this sheet, you have to draw, means here the line to line voltage of this is 0 axis here is given to you, that is the EBC. In my lecture always I took the EBA is the starting voltage, because this was the commutation voltage of valve 3, but this time here I have changed, and now we will see what will be the commutation voltage of this valve. You can see from here also it is you can see the BC, means B is positive side, it is a B, and another side it is a C. Here which valve it is, you can see the C is involved, means it will be maybe possibility of this limb, because C is there, or they are conducting before. Now, you see what will be the commutation voltage of this valve. Before that what was conducting? The 4 was there. So, no, before this your 6 and 1 are conducting. So, this is coming your EB, so it is your EB, here EC, so this minus this, so here it is EBC, means this is the commutation voltage of valve 2. If you are confused, do not worry, you remember the commutation voltage of valve 3 is EBA, it is okay, because whole the class we just defined and it was there. Now, just mark the line to line voltages. So, as I said, it is EBC is given to you here. Now, after 20 degree, just we can go for here, it is your ECA, here it is EAB, and sorry, now after again we are going to here EC, oh it is A here BC, sorry. Now, we can see this is a reverse of this, so it is your EBA, here this is reverse of this, it is your EAC, and this is your ECP. So, now as we know that is EBA, this voltage is the commutation voltage of valve 3. This is well known. So, if you are not going here to check which valve is starting, because I have given your 0 axis start from here. So, it is no problem, you can just see it is your EBA here is your commutation voltage of valve 3, means valve 3 from here it can be fired, and the alpha is 50 degree, means we here the 60, 120, and here it is going to be 180, means in between here. So, this is your valve 3 is going to be fired. Now, after every 60 here 2, 1 and 6 will be there, or you can start there and then you will come back, because it is one cycle is asked. So, I can say here at this point here it is your valve 3 is being fired, or you can see your EBC here it was your here it was your 2, as we see this EBC was your the commutation voltage of valve 2. So, your alpha here from I can say from here it is your alpha, and this is equal to your 150 degree, or I can say your beta from here it is your beta degree, that is 30 degree. Now, you can see just every 60 degree you are going to have another one, means here you are going to have your 1, here you are going to have your 6. Every 60 degree just move, that is here half of this, here your 4, here you are going to be your 5, here you are going to be 6. Once you have marked the line to line voltage, once you have marked the instant where they are going to fire, then whole sequence and whole drawing it will be very simple. Now, we can start from anywhere and then we can draw. Let us draw from here. I am saying this 1 is being fired. Let us start from here. Yeah, you can start from 2 because the EBC is given to you the commutation voltage of valve 2. Here we are just firing your at this value we are giving the pulse 2. Now, before that your 6 and 1 were conducting, and the 2 is given here pulse. Now, your 6, 1, 2 are conducting, means just here for few degree 6, 1 and 2 are now conducting, and this will be for 15 degree it is given to you, means here it is a 30 degree, means it will go up to here, sorry it will go up to here, the 15 degree of half of this. Okay. Now, see what will be the voltage when your 6, 1 and 2 are conducting, output voltage. See it here, 6 is conducting and 2 this side. So, this is your EB and this, so it is minus EA by 2, and your 1 here it is your EA. So, this minus this it is 1.5 EA. Now, see where is the EA. If you will find, you will see this your minus EA is here. This is your 1.5 EA, minus, sorry. Okay. So, it will be the positive will be just down here, and this will be your this voltage here. So, okay. So, now what happens here, your output voltage will be this one, because your this is your nothing but I can write here is your 1.5 EA, this curve is going, because it is just opposite of this. Now, after U means after 15 degree commutation is over between here and here, now we are 1 and 2, and 1 here is your EA and 2 is your EC. Here your output voltage is EAC, and now we see where the EAC. EAC now we can see, you see this EAC is this curve. Now, where the EAC? EAC is coming all the way here, here. So, suddenly it will go here and then it will follow EAC. Means in this graph I can draw, once commutation is over means it is coming to EAC and then it is following here up to here next valve. This is your EAC. Now valve 3 is given a pulse, means your 1, 2, 3 are conducting, and then what will be the 1, 2, 3 means here it is your this, here it is EC minus EC by 2 and here EC. So, this minus this is minus 1.5 EC and see where is the EC, and you see this is your C is your positive C is here, this is your 1.5 EC and it is negative. So, it will be coming down here all the way and we are going up to here and here it is coming here, then it will follow up to U degree where it is your 1, 2, 3 are conducting, then it will go back and it will follow EBC because this will be here your 2 and 3 will be conducting, because when 2 and 3 are conducting, here 3 means B and here is C, EBC means it is following EBC, you can say. So, now it will be following all the way here, means our symmetrical component symmetrically he will find here, this is going to be this and we are going to get all the way the similar patterns here and we can come back here again. This is 6 is given pulse here. So, this your output voltage is this and we are going to have here, then we are going to have here. So, this is your valve voltage, means you can draw for few here and then you will find it is repeated because all the things you will be symmetrical here. But in the case if it is there is some misfire or the commutation failure, then you have to be careful and you have to draw for all the cases, because here it is said it is a normal commutation, means here we are getting this type of voltage and then you can after going 3 and 4 you can repeat because it is a symmetrical, it will be coming for every 60 cycle you are getting the same one. But sometimes I say here for example, we will see later on if valve 3 got the pulse but misfired, then the means 1 and 2 is continuing to conduct, then you have to follow it and then at that time each instant you have to see. So, this was your output DC voltage and you can say it is a negative, means it is a inverter operation. Now, it was asked to draw the valve voltage for valve 4, means this fellow was asked that what is the voltage this is experiencing in this whole scenario. Now, you can see whenever the 4 will be conducting, the voltage will be 0. So, you can see when 4 is getting pulse here at this point 4 is getting pulse, means it will be 0 onwards till it will be off. So, now here I can say the this is your this starting, we can start, it is going here 5th is fired. Now, after that 4 5 is conducting, now here 3 4 in this duration you can say what is conducting here 2 3 4, then 3 4, here 3 4 5, then 4 5, here it is your 4 5 6 up to certain duration here and then here it is 5 and 6, means it is off. So, it is going to be here up to this point, this will be 0, or we can coming this side here, means when the 6 is going to be fired here and then after that it is your voltage is 0 here, we are reached the cycle here. Now, I come back here. Now, during this period here we are going to experience the valve 4 will experience some voltage other than 0. So, now see it here, here as I said here it is your 5 and 6 are conducting, because it was here 4 5 6 commutation between 4 and 6 is over, means 6 is conducting. So, now 5 and 6 are conducting, what will be voltage here? Once 6 is conducting here, it is your EB here, means the voltage here it is EBA across that. So, you see where is the EBA? EBA is here, yeah, this is EBA, means here it will come here and it will follow this voltage till 1 is going to be fired. Once 1 is going to be fired here, means before that your 5 and 3 are conducting. Here the voltage at this point what is going to change, because this is your EA and this is your EC, means here this voltage is minus EB by 2 and lower one was what? 6 was conducting. So, it is EB. So, it is 1.5 EB will be there and it is a positive, because this EB minus here minus 1.5 0.5 EB. So, 1.5 you have to see where is that. You will see this is your EB, this curve is 1.5 EB positive. So, what happened? It will be going somewhere here for this duration, only u duration here, and then it will come back again. Okay? Because once commutation is over, now you are again your, and this period you are having 6 and 1 are conducting. Is okay? So, again here this is your B and here is A, it is not 6 1 is conducting. Yeah, is a 6 1 is conducting. So, it is EA. So, we are again going to have this EBA and now it will be not changed till you are going to fire second. So, this will be your, you are here, now you are reaching at this point, now you are giving the pulse to 2. Now, you can see here the commutation between these is going to happen. Now, it is your minus EA by 2 is going, because this is the EB, here EC and then by 2 is this point. So, it is going to be this, and then this side it is your EA. So, now it is a minus 1.5 EA and now you can see where is this, this is your, this curve is your, already I have written 1.5 EA, means it is coming here, it will be up to u degree and then it will be going back again. Once commutation is over, it is going back and then it will again EBA will be there. No? It is not, yeah. Here, see, this we reached here, sorry, up to this point. Now, you can see what will the voltage once the commutation is over, means we are going to have 1 and 2. Here is the change, now it is this voltage is going to be EC. So, here it is your EC here. So, we have to go for the ECA and your ECA is from here, sorry, it will be going to be here, this is not there. So, it is from here, it is coming here and then it will follow ECA. Normally, it is always we do the mistake at this point only, means from here whether it will go up or it will go down, because here the sequence is changed, it is 1 and 2 are there and 1 and 2 you can see the 2 means C and 1 and that is always that side is negative side is EA. So, ECA will be there. So, it will follow here, suddenly coming here and it will follow there. So, it will continue here till again the next here pulse is, it is going to be given for 3. Once you are giving 3 here 1 and 3 here again, now the commutation is taking place. So, now this value will be, this voltage will be your minus EC by 2 and this side it is your EC. So, 1.5 EC will be there and 1.5 EC will be your this curve. So, we are having here, now it will be going for this and but again now it will be coming all the way here. So, this value is your 1.5 EC. Once commutation is over again, now it is your 3, 2 and 3 are conducting. So, again you can say hardly matter here, the C is coming, A is there. So, it is again ECA. So, it is again following this ECA and it is going to be here till again we are going to have the fourth. Once fourth we are giving the pulse, now what will happen? It will be suddenly 0. So, this was your valve voltage which was asked to draw for the valve 4. Now, you can see it is so simple. Only just you have to monitor the which one is conducting, what will be the voltage and you have to be careful about this here when the 3 valves are conducting. And it was asked to you and this is the problem which just I said that you can go ahead with this. It's clear? So, I could not, as in this lecture, I could not explain the converter chart. We will discuss in the next lecture. But the problem is very important because you should be very, very careful here without knowledge of this valve voltages and the output voltage, because sometimes misfire, sometimes commutation failures, other things, and also we will see other how to protect the valve, etc. That is very, very important once you are knowing the exact output voltage of this valve. So with this, I can stop here, and next lecture we'll discuss about the converter chart, which is very useful. That looking at the chart, you can say what is the U, what is alpha, what is the gamma. Based on the chart, you can know it without any calculation, etc. So thank you.